Next, we'll move on to the Floyd and Warshall's algorithm. Directly from Wikipedia, I'm explaining this Floyd-Warshall algorithm. Once you understand the concept of the Dijkstra algorithm, Floyd-Warshall algorithm is very easy to understand because Floyd-Warshall algorithm is a specialized algorithm that will work in the when the edges are negative also. Even though the edges are negative, the Floyd and Warshall algorithm will work. And at the same time, Floyd-Warshall algorithm is having little bit higher time complexity than the Dijkstra algorithm. Anyhow, somewhere we have to compromise. Even though it is having the advantage of working with the negative edges, it is having the disadvantage of higher complexity, higher time complexity compared to the Dijkstra algorithm. Dijkstra algorithm time complexity is order of v square, where v is the number of vertices. Where in case of Floyd-Warshall algorithm, the number of the time complexity is order of v cube. Okay, the worst case performance is order of v cube, best case performance is order of v cube, average case is order of v cube. So worst case is order of worst case space complexity is order of v square. Now we will see this algorithm. This algorithm is a very simple algorithm. The algorithm is like this. Let distance be v into v, that is total number of vertices, array with minimum distances initialized to infinity. That means the minimum distances, that means if there is no connectivity, infinity will be initialized, otherwise the corresponding weight will be placed, as just like the matrix initialization made here. If there is no path or if there is no edge between the vertices, you are going to declare it as infinity, otherwise the corresponding weights are initialized here and placed. Next, for each edge u comma v, do distance of u comma v is equal to weight of u comma v. So the weight of the edge will be placed in the distance of u comma v. This is a two-dimensional matrix that is used for calculating the minimum distance. So initially the minimum distance matrix is initialized with the weight of the edge of u comma v. For each vertex v, do if you are referring to the same vertex, that means 0 to 0 or 1 to 1 or 2 to 2, like that, that particular vertex distance should be initialized to 0. Other than the self-referencing edge, that means since there is no self-referencing edges, we are going to use here, and we are going to use only straightforward edges, then the corresponding weight will be placed here. For k is equal to, for k from 1 to v, so you are supposed to consider all the vertices, and you have to pick one vertex from that, and you have to pick the adjacent vertices, and you are supposed to make the comparison. This is just like the single source shortest path algorithm that we have discussed in the previous lecture. So algorithm, shortest path, here the v, cost, distance, n. So v is the vertices, cost matrix, distance matrix, and number of vertices. For I is equal to 1 to n, first you initialize the matrices, distance is equal to cost of v comma I. Then for number I is number is equal to 2 to n, do choose u from among those vertices not in S such that the distance of u is minimum. You pick one vertex, assume that starting vertex is 0, you pick the starting vertex, and for each vertex adjacent to the u, you are supposed to calculate like this. If distance of w is greater than distance of u plus cost of u comma v w, then the distance must be updated. Here for k from 1 to v, for I is equal to I from 1 to v, and for j is equal to 1 to v, distance of I comma j is greater than distance of ik, that is any of the intermediate node between the source and destination, plus from that particular intermediate source to the intermediate node to the destination. Then you are supposed to update this. that is distance of I comma j is equal to distance of I comma k plus distance of k comma j. That is, assume that I have direct path from S to U, but I have to check whether S to U path is greater than S to X and X to U. Okay, so that means this is assume that this is S and this is U. Distance of SU is greater than distance of SX plus distance of XU. Then you are supposed to update this particular distance. That is, if the distance of SU is greater than distance of SX and distance plus the distance of XU, then you are supposed to update the distance of SU is equal to distance of Sx plus distance of XU. That is, the minimum cost will be updated at the with the source. So this is the way you are supposed to do this. Just by observing the for loops, here three nested for loops are there. It is just like looking like a matrix multiplication. You are going to use 3 for loops here. Whenever you use 3 for loops of same length of number of vertices, then obviously the time complexity will become order of v square. Okay, sorry, v cube. This is called worst case, for the worst case, best case, and average case. In all these 3 cases, the time complexity is order of v cube. So this is the program how it will execute. That is, let us assume that this is the graph. Okay, 1 3 1 2 3 4 like this. First, what it will do is, in the initial round, from 1 to 3, the estimation will be done. 2 to 1 estimation will be done. 4 to 2 estimation will be done. 2 to 3 1 estimation will be done. Like that, the distance calculation will be done. Now in combinations it will do 1 to 3, 1 to 3, and 3 to 4. Okay. So for that, the iteration will be like this. Here 1 to 3 is there. Next 3 to 4 is there. Okay, 1 to 3 and 3 to 4. Here this combination is there, and this combination will be like this: 2 to 1 and 1 to 3. So 2 to 1 and 1 to 3. That means the direct calculation 2 to 1 here in the first round. Next 2 to 1 and 1 to 3. Instead of 2 to 3, for this for the 2 to 3, it will calculate from 2 to 1 and 1 to 3. So like this, a pairing of comparisons will be done. In the last round, what will happen is 3 4 2 will be calculated. 3 4 2 1 will be calculated. 1 3 4 2 will be calculated. So like that, pair of in every iteration, the pair of vertices path will be calculated, and in which whatever the minimum path is there, that will be considered. By the end of the last round, that particular set consisting of the path with the minimum weight. This is what the Floyd-Warshall algorithm, and this is a very simple algorithm to implement and easy to understand also, and also will work with the negative weights. Here, this is the program to demonstrate Floyd-Warshall algorithm, shortest path algorithm. Same graph I have considered. You can download the PowerPoint presentation. From there, you can observe this graph. And also, the source of the algorithm is from the Wikipedia, so I have given the reference here. So the graph, S graph, is the static graph that I have mentioned here. The path, the two-dimensional matrix I have mentioned here. Floyd-Warshall's underscore single source. In previous Dijkstra algorithm, we need to give from starting vertex, but here I am not giving starting vertex because it was not mentioned in the algorithm, because we are going to directly straight away starting with the zero starting vertex. So we no need to mention anything here. Next, int distance of the number of vertices, number of vertices. Here for I is equal to 0, I less than number of vertices, I plus plus. For int j is equal to 0, j less than number of vertices, j plus plus. If I is equal to j, you are supposed to place distance of ij is equal to 0. So according to the wiki algorithm, distance of v, that means if the same vertex is there in the for loop, if it is repeated, then initialize it with 0, otherwise initialize with the weight, corresponding weight. So the same thing I am implementing here. Okay, so else distance of ij is equal to adjacency matrix, that what I have entered, its corresponding ij values. Now for each vertex, choose a vertex I from among those vertices in the list, compare with each vertex adjacent to that particular chosen vertex. Now the same 3 for loops that was mentioned here, the same as it is I have implemented. Then finally display the matrix. So while displaying the matrix, it will print the matrix with the shortest distance. So in the main method, I have called the function Warshall underscore single source the static graph. The static graph means here that I have mentioned at the time of declaration. Now let will run the algorithm program and we'll see the output. Well, here 9999 is there, which is the infinity. So 07395, that means 0 to 1, the shortest path is 7, the cost is 7. 0 to 2, the cost is 3. Like that, the matrix we got it. So after observing this matrix, we can easily identify what is the minimum cost distance from one place to other place. Here we are not recording the path, but however we are recording the cost. You can record the path in this for loop. If you find this is the best path, then insert this particular path in the queue. This is the only modification you can do to save the path. So this is what the Warshall's algorithm, which will work with the negative edges or negative weights, and at the same time which will give you the time complexity of order of v cube, where v is the number of vertices.